Okay, we're back with a few more examples of solving quadratics by factoring. Let's just start with this guy on the left over here. And it kind of looks like we have factors already. We have a binomial factor here, a binomial factor there. However, when it comes to solving the equation, we're going to have to go, let's just say, backwards before we go forward. It's really all forward, but what I mean is we're going to have to distribute first. Then combine like terms, get everything all on one side of the equation and go from there, and then refactor. So what this gives me on the left side then is 2x squared plus 5x on the other side. 2 times 36 is 72 minus 2x. I want everything on one side of the equation. So I'm going to subtract the 72. I'll just put that over here since it doesn't combine with any of those guys. Add the 2x to both sides. Add the 2x. Okay. Oof. And what I get is 2x squared plus 7x minus 72 equals 0, written in the standard form. And I'm going to attempt to factor this from here. Now, I've showed method 1, I've showed method 3. Why not do one with method number 2? So method number 2 starts like this. Multiply these two guys. That gives me negative 144. And now I need to factor negative 144 into two things that also add to 7. And I'm going to cut to the chase here. It's 16 times negative 9. Okay, there are a lot of things to try. One technique is to do the prime factorization of 144 to see all the numbers that multiply to give you 144, and you can play with the products so that you end up with the right sum that gives you 7. And 16 minus 9 is 7. 16 times 9 is 144. Positive times negative is negative, so we got all that taken care of. Now, for method number 2, what we do with those two guys, remember, is to expand the middle term. So this gives me 2x squared plus 16x minus 9x minus 72. All of that is still equal to 0. We're just trying to factor this. And now we are going to group each pair of these terms and factor out the greatest common factor from each one. So I can take a 2x out of this, and I'm left with x plus 8. I can take out a negative 9 here, and I'm left with x plus 8. All of that is still equal to 0, but this is not helpful yet because I have that minus sign. I need everything multiplied together to equal 0. That's okay. We're going to take one more step by factoring out the x plus 8. And what remains that it was multiplied by is 2x minus 9. Remember, this is method number 2, what I call method number 2. Maybe these have specific names, but we're expanding the middle term, and then we're factoring by grouping. And here are indeed the two factors that I was hoping for to use the zero product principle to solve the equation. From here, I can say that, x plus 8 is equal to 0, or 2x minus 9 is equal to 0. For the first equation, I can simply subtract 8 from both sides, and I'm going to write the solution up here. That gives me x is equal to negative 8 for one of the solutions. The other one, I'm going to have to add 9 and then divide by 2. I'm kind of running out of space here. Let me just add the 9. Add the 9, and so that gives me 2x is equal to 9. Divide both sides by 2, and we get x is equal to 9 halves is the other solution for this problem. Remember to check the solutions. We can take each of these solutions independently, plug them into the original equation. When the left side equals the right side, if it equals the right side, you know that you did it correctly, you got the right numbers. Please double check my work. I leave that to you. Let me move on to the other examples. The next one, 16x squared equals 25, is actually, I think, better solved in a different way. Divide both sides by 16 and then take a square root. And we'll do that. We'll talk about solving by roots, but right now we're still trying to solve by factoring. I want to show you that this actually can be factored, and it's not too bad. It's kind of nice. First, we're going to subtract 25 from both sides. I'm going to write it kind of sideways just to remind myself it's not a like term. So that gives me 16x squared minus 25 equals 0. This is a special form that you should recognize immediately as a difference of squares. This term is something squared, this term is something squared, there's a minus sign. It is a difference of two squares, which always has a nice factorable form, so I can go directly to the factors, which are 4x minus 5 times 4x plus 5. And that's equal to 0. Then we're going to set each of these equal to 0 using the zero factor property. So 4x minus 5 equals 0, or 4x plus 5 equals 0. Solve both of those equations, and I'm just going to print the solutions right here in set notation. I'm going to say x is equal to, from this one I get a positive 5/4. From this one I get a negative 5/4. And please take the additional steps to verify that I got this correct, that I did it correctly, and that indeed both of these are solutions to the original equation. Okay, last example in this set of examples. X squared plus 2x plus 4 equals 0. The coefficient of x squared is 1, so I am going to start by looking at the factors of 4. 1 times 4, 2 times 2, also the negatives. Negative 1 times negative 4, negative 2 times negative 2. But do any of those factors add up to 2? No. So what I'm going to say about this right now is it's just not factorable. Not factorable. It does not mean that there are no solutions to the problem. It just means you got to do something else. So I'm going to put that also. All this means is that you need another method. Need another method. Okay, such as completing the square or using the quadratic formula, which actually comes from completing the square. So we're going to leave it alone for now for this lesson on factoring. Say, well, we need a different technique. We'll come to that at a different time. Stay tuned for applications.